Good morning. This is Jitendra Kumar, and I will deliver some important questions regarding material science. I have already delivered three important lecture of material science, which can be seen in my YouTube channel. So, I am going to conclude all important questions on the basis of previous three video lectures. So these questions are important as per interview point of views, and you need to command over these questions. If you will have good look over these questions, then of course there should not be any problem while you facing any interviews of corresponding examinations. Okay, so let me start. So first question is, this is very basic question, because whenever material science starts, so first question, very important basic questions is, what is phase? So I have explained in brief in my video lectures. Just I am giving short views so that it can be revived quickly regarding important points and some topics. So first question, just I am repeating, revising these questions one by one. First question is, what is phase? Phase is physically distinct, chemically homogeneous and mechanically separable mixture. It's called phase. Physically distinct, chemically homogeneous and mechanically separable. This mixture is called phase. Next question, what is phase diagram? Phase diagram is the map on temperature, composition, space, which shows the stability of different phases. It is very important, just need to understand the basic words whichever used in these definitions. It is map of temperature, composition, space, which shows the stability of different phases. It is map of temperature. This just we have already explained some different phase diagram in our lectures, video lectures. This temperature is represented on y-axis. Compositions are represented on x-axis. For binary phase diagram. On a space, because this space may be either 2 dimension or it might be either 3 dimensions. 2 dimensions, when there is a binary phase diagram, this phase diagram will be shown in 2 dimensions, that is in x-axis and y-axis. But whenever ternary phase diagram is studied, then this phase diagram is shown in 3 dimensions. Okay, so we'll discuss later on. So first of all, we have to understand clearly what is phase diagram. The phase diagram is the map on temperature, composition, and space, which shows the stability of different phases. Right? In other words, it can be explained in different ways, that the melting point of alloys can be viewed, can be seen by the help of phase diagram. So there are so many points, there are so many critical points, eutectic, eutectoid, peritectic, peritoid. Just we will discuss later on in further videos what are these points. So in short, in one line, if somebody is asked what is phase diagram, then you can say that the melting point of alloys can be studied, can be viewed with the help of phase diagram. Okay, so there are two definitions. One definition, the phase diagram is the map of temperature, composition, space, shows the stability of different phase, or it can be said that the phase diagram, with the help of phase diagram, melting point of alloys can be found out. Okay. Third question, what is degree of freedom? Degree of freedom defined as number of independent variables. Number of independent variables required to specify any matter. So degree of freedom, it is defined as number of independent variable required to specify any matter. This is called degree of freedom. Next question is, Gibbs phase rule. As we know, we have discussed in previous lecture, Gibbs phase rule is represented as P plus F is equal to C plus 2. P plus F is equal to C plus 2. That means where P is phase, F is degree of freedom, and C is number of components. Okay, so this P plus F is equal to C plus 2, right? Okay, good. Now we will discuss. Next question is classify phase diagram. Okay, first of all, we have defined phase, later on this phase diagram, then degree of freedom. Now the next question is, how this phase diagram is classified. The phase diagram is classified on the basis of composition as unitary phase diagram, binary phase diagram, and ternary phase diagram. This phase diagram is classified into mainly three categories: binary phase diagram, unitary phase diagram, binary phase diagram, and ternary phase diagram. As name suggests, unitary phase diagram means composition will be 1. Number of composition will be 1. For binary phase diagram, number of composition will be 2. For ternary phase diagram, number of composition will be 3. So these are all about the classification of phase diagram on the basis of number of composition, number of components. Like C, we have already discussed in Gibbs phase rule, P plus F is equal to C plus 2, where C is number of components. On the basis of number of components, this phase diagram is classified into mainly three categories: unitary phase diagram, binary phase diagram, and ternary phase diagram. Okay. Now, the next important question is, on the basis of this phase diagram is classified in further three different types on the basis of mixing of alloys in liquid and solid phase. So type 1, the first type 1 is this materials, because this number of, we are studying classification of binary phase diagram. Now how this binary phase diagram is classified. How this binary phase diagram is classified into different categories. So binary phase diagram is classified into mainly three types. Type 1, the materials which are completely soluble in liquid as well as solid state. The materials, suppose that since we are studying this binary phase diagram, that means number of components will be 2. So these two components will be completely soluble in liquid as well as solid state. That means in liquid state they are soluble, but in solid state they are also soluble. This is important. So this is type 1. the materials which are completely soluble in liquid as well as solid state. This is important. For this type, the copper nickel is the best example. Copper nickel is one of the best example of this type. We have discussed in brief in second video lecture how this copper nickel phase diagram is shown. So for detail, just go through my second video lectures. In short, some important points, some important highlighted points I will explain in this video. First important point is, since copper nickel, so melting point of copper is 1100 degrees centigrade. Next point, melting point of nickel is 1452 degrees centigrade. Lever arm rule. With the help of lever arm rule, just we have can calculate mass fraction of liquid and solid. So this mass fraction of liquid and solid has been shown in second video. The governing equation of lever arm rule, there are two governing equations, ml plus ms is equal to 1, where ml is mass fraction of liquid, ms is mass fraction of solid. mlCl plus mscs is equal to CO, where Cl is a percentage of nickel in liquid phase and Cs is a percentage of nickel in solid phase. So with the help, while solving these two equations, we can find that the mass fraction of liquid is equal to Bc by Ac, where Bc is Cs minus Co divided Ac, Cs minus Cl, and mass fraction of solid is equal to Ab by Ac, where Ab is Co minus Cl divided Cs minus Cl. So this is the important formulas on the basis of this type 1 phase diagram. That is copper nickel, since both can be mixed, both are mixed in liquid as well as solid state. So this is important, since it is said that both can be mixed in solid state also. Why? Because both the copper and nickel atom mixes with each other at atomic level. Both are mixes at atomic level. Therefore, this copper and nickel appears in single phase in solid state also. So this is very important. Why this copper and nickel can be soluble in solid state also? Because both atoms mix with each other at atomic level. So this is important point. So this is all about the type 1 phase diagram. This is the materials which are completely soluble in liquid as well as solid state. Next type is materials which are completely soluble in liquid but partially soluble in solid state. So in this section, this PBSN is the example which has been explained in third lecture of my videos. So for detail, go through the third lecture of this one. We have explained in this type eutectic mixture. Eutectic means nice melting. Eutectic mixture is this liquid, while during solidification, the liquid converts into two different solids. This is alpha plus beta at 183 degrees centigrade and 62% Sn. This is called eutectic reaction. This is first important point. Eutectic reaction. Liquid converts into two different solids. This different solids is alpha and beta. This temperature is 183 degrees centigrade and composition of SN is 62%. This is an important point you need to remember. Next point is degree of freedom. This eutectic reaction are invariant reaction. This eutectic reactions is invariant reaction. What does mean invariant? Invariant reaction is defines that for invariant reaction the degree of freedom will be 0. For invariant reaction degree of freedom will be 0. For this one, this modified Gibbs phase rule as follows. This P plus F dash is equal to C plus 1. P plus F dash is equal to C plus 1. This is the important point. This alpha phase, the solid solubility of SN in Pb. Alpha phase is solid solubility of SN in Pb. That means alpha phase defined as maximum (16% of SN can be dissolved in the structure of Pb. This is called alpha phase. Beta phase is solid solubility of Pb in SN. Maximum 3% of Pb can be dissolved in the structure of SN. So this is called beta phase. That is solid solubility of Pb in SN. So alpha phase solid solubility of SN in Pb, and this beta phase is solid solubility of Pb in SN. So this is the important point. Third type is materials which are completely soluble in liquid but insoluble in solid state. This is bismuth alloy. Bismuth alloy is one of the best example of this one. So these are the classification of binary phase diagram on the basis of mixing of these materials in solid and liquid states. Okay, thank you.